So last class we were discussing about several memory components. We discussed about what is shared pool, then database buffer cache. Then we talked about what is a large pool, then Java pool, all those things. So we need to look at the background processes now, starting with the SMON. But well, before going and understanding about SMON, we need to understand a little bit about the redo log files. So already we understood in the last class what is a redo entry and what information it is going to store. So once again I am reminding you people. So redo entry is nothing but whatever the change happened to the database, that is going to be recorded in redo entry, and it stores some information like what is the table name, in which table the change occurred, and in which table space this table is residing, and in which block actually the change occurred, and what is the date and time in which the change has been occurred, and it is also going to record what is the new value that we are going to insert. So like this several information will be listed, and along with this Oracle is going to store in the redo entry itself. Oracle is going to store a number which we call it as SCN. So stands for System Change Number. So the definition of SCN says a number or a unique number, I say, assigned to a transaction which tries to modify the data. So this is what the definition says: a unique number that was assigned to a transaction which tries to modify the data. So here the last word is important, or this word is important, which tries. That means just an attempt to change or to modify the data is enough to generate a SCN number. So it is not like only committed transactions will have SCN, or only rollback transactions will have SCN. Whenever you try to do any DML or DDL, immediately SCN will be generated, whether that is committed or not committed. Oracle doesn't care about it. And more of a kind, SCN at database level will be treated as a timestamp. So because Oracle cannot record, in Oracle usually all the transaction happens in nanoseconds or microseconds of time. So Oracle cannot keep on recording even the nanoseconds or the microseconds information. So what usually it will do is it will keep track with the help of this SCN number. So even this information also will be recorded in redo entry. So like this, some information will be there in the redo entry. And in DML statement processing, we understood that whatever the redo entries that are generated in PGA, so those redo entries will be copied to log buffer cache, and from log buffer cache a background process is there by the name log writer. So that background process is going to write that to redo log files. Now the thing over here is when you look at an example when we are discussing about DML processing, we have taken an example like updating a row from a value of 100 to 200, and when we are updating only one row, we are getting two redo entries. That means for every X number of rows modification, there will be double the size, double the redo entry generation. So if you go and modify 100 rows, there will be 200 redo entries. If you go and modify 1000 rows, there will be 2000 redo entries. So something like that. So if you modify X number of rows, there will be 2x number of redo entries. So when this much huge redo entries are being generated continuously, then what happens is when log writer is continuously writing into redo log files, then the space might not be enough to hold that particular data. So for example, you are updating 1 crore records, then what happens automatically 2 crores of video entries will be generated, and that is going to be stored in the redo log files. So that means to store those 2 crore redo entries, you might need some redo log files. But if this process repeats and every now and then your database is hitting with a bigger transactions, then what happens is ultimately your redo log file size will not be enough. So uh, to manage or to maintain this Oracle architecture with less space that is required, how Oracle designed its architecture is, instead of maintaining one redo log file, we will be maintaining two redo log files, and Oracle will write into both of the redo log files in a cyclic order. So as you can see on the diagram uh, now, there are two redo log files. So we say it as redo log number 1 and number 2, and you can see the arrow marks which are switching from number 1 to number 2, then number 2 to number 1, which means that log writer is going to write into them in a cyclic order. So when log writer is keep on writing in a cyclic order, every time what it will do is it will overwrite the previous content. Suppose log writer completed writing into first member, and it has started writing into second member and or second file, and once again it comes back to first file, then whatever the previous information is there, that information will get overridden or log writer will override it. So that is what usually happens. And suppose if we don't want the previous information to be overridden, we want to take a backup of that, because we can't avoid log writer or we can't stop log writer from overriding the data. So rather what we can do is, before log writer overrides that data, we can take a backup, and that is possible only when you enable something called archive log mode in the database. And when you enable this archive log mode, then a background process, a new background process we will be seeing in the outside of the box. So I'm just showing you that. So there is a background process called archiver. So here you can see that. So which is outside of the box. So whenever you enable archive log mode, what is a new background process will be created by the name archiver, or shortly we call it as ARCH. And this background process is going to copy whatever the redo log file content is there into some other destination or some other place. So by this we can say archiver is going to copy the data from the redo log file to any other location, and the copied files, we call them as archives or archive redo log files. So basically archive redo log files, in the architecture you can see that component. So that component is nothing but the copy of the original redo log files. So that's how we can manage to have older data in place. Otherwise a log writer every time is going to overwrite the data again and again. So is this point clear, or any queries before we proceed further? Yes, Pani. Archiver will take the backup of only redo log files. Okay, so that is what the first 2 points are talking about in the architecture. So we know that logger will write the redo entries into redo log files, but if we have more and more redo entries generated, then redo log file size also will increase, and even terabytes of storage is not sufficient. So to overcome this, Oracle designed its architecture in such a way that logger will write into 2 or more redo log files, that too in a cyclic order. So if you look at the diagram here, there is a below this arrow mark you can see something called log switch. So what exactly is a log switch means, you can see below logger moving from one redo log file to another redo log file, we call that as log switch. And during the time of log switch, there are some activities that will take place in the database. So starting with the first point, checkpoint event will occur. So whenever log switch occurs, log switch means logger moving from one redo log file to another redo log file. So during that time, there are some activities that will be performed. The first activity is checkpoint event will occur. So what exactly mean by checkpoint event? You can read there. This will tell that the dirty blocks should be made permanent to the data files. So that means whatever the dirty blocks that are generated till that moment of time, they should be made permanent to the data files. So how the dirty blocks will be made permanent to data files? Only when DB writer writes them. So the meaning of checkpoint event is whatever the dirty blocks that are there in the write list, so those dirty blocks should be written by DB writer to the data files. And example, it's like automatic email saving. We have that option in Gmail. So whenever you are trying to compose a very big email or you are taking some time, then what Gmail or Google will do is, if after every certain period of time, your email will be saved automatically, so you don't require to lose any information. So in the same way, after a certain period of time, even what Oracle will do is, it is going to make the data whatever you ask it for permanent. So this is what checkpoint event will make sure that. And then we have the next background process as CKPT, so which we also call it as checkpoint process. So checkpoint event is different, CKPT process is different, even though the names are very similar. So what this CKPT process will do is, it is going to update the latest SCN to the data file header and with the control files. So every data file will have a header portion. More about this we will be discussing at later point of time. And control file. So whatever the latest SCN that was generated, so that SCN number will be returned to the data file header and control files. Now the question here is, from where CKPT process will get that SCN or the latest SCN? So it is going to get that latest SCN from the latest redo entry. So that is what you can see in the point. It says CKPT process will update the latest SCN to data file header and control files by taking the information from the redo log files. So in the redo log files, whatever the latest entry is there, so that will be considered as, or that will be containing the SCN. For example, so let's assume this is my redo entry, the last redo entry or the latest redo entry. So as I said, definitely every redo entry contains of SCN number. So this redo entry also will have some SCN. So let's assume the SCN is 1, 2, 3, 4. So what Oracle will do is, it will write this 1, 2, 3, 4, or what CKPT will do this is, it will write this 1, 2, 3, 4 to the data file header as well as the control files. And as a third step, the database writer will write the dirty blocks from the write list to the data files. And if the database is enabled with archive log mode, then archiver process will generate the archives. So these are the 4 activities that will take place during log switch. So checkpoint event means automatically saving your data after a certain period of time. Checkpoint process, it is going to update the latest SCN to data file header and control file, and this is because of some reason that we require that SCN will need to be written. We will come to know shortly. And as a third step, database writer will write the dirty blocks from the write list to data files, and then archiver process will generate the archives. So that is only if the database is in archive log mode. So is these 4 points are clear? Yeah, SCN is, as we discussed just now, SCN is a unique number. I hope you can see the notepad. So it is a unique number that was assigned to a transaction which tries to modify the data. So suppose I have issued some update statement. So what Oracle will do is, for that update statement it will assign one number. Okay. Now whether that update statement is committed or rollback, Oracle doesn't care. So just the moment some DML or DDL statement hits the database, immediately it is going to assign one number, and that we call it as SCN. Full form is system change number. So any more queries? Okay. So now there is a note here. You can read this. So the note says checkpoint event will not only occur at the time of log switch, but it can also occur at a repeated interval. So usually whatever the checkpoint event we discussed, it is going to tell to Oracle that the data blocks or the dirty blocks should be made permanent to data files. So this checkpoint event will not only occur at the time of log switch, but repeatedly in some interval it is going to happen. Till A-type, we use it to decide the time frame with the help of a parameter called log underscore checkpoint underscore interval, as you can see on the screen. So for example, if I set log checkpoint interval is equals to 60 seconds, that means every 1 minute one checkpoint event will occur. Or if I set to 20 seconds, every 20 seconds one checkpoint event used to occur. But from 9 onwards, instead of using this log underscore checkpoint underscore interval parameter, we are going to use a different one, that is fast underscore mttr underscore target. Sorry, fast start mttr target. And this is from 9, and by default this parameter will be having a value of 0. That means whenever you see this parameter value as 0, we need to understand that Oracle will take care of checkpoint event generation. So if you clearly specify fast start mttr target equals to 30, then every 30 seconds one checkpoint event will occur. But the default value will be 0. That means Oracle will decide when to initiate a checkpoint. So we don't require to bother about when checkpoint will occur and when checkpoint will not occur. So that is what basically happens with that parameter. Now let us go and see what are the responsibilities of SMON, what it will be doing and all. So the first one is, you can read on the screen. So it is a background process which is responsible for the following actions. The first action or the first responsibility is instance recovery. So now before we understood about instance recovery, usually we will be going and doing recovery only whenever there is a crash occurred. So if instance recovery is being performed means instance crash might have occurred. So we need to understand what is meant by instance crash, when it may occur, all those things. So instance crash is nothing but whenever your RAM got failed or whenever all of a sudden power failure occurred and your database server is down, in those situations instance crash will occur. So when I say instance crash, whatever the memory that was allocated on whatever the background process that are running, so all got closed all of a sudden, and we call it as instance crash. So whenever instance crash occurred, SPON will take the responsibility. The next time when you start the database, it is going to take the responsibility of doing the recovery. So how it is going to do the recovery? There are certain phases that we need to bypass. The first one is roll forward. So what roll forward will do is, it will compare the SCN number that is there between the redo log files and data file header, and it will make sure that the committed data is returned to data files. Then the second responsibility, second step in this instance recovery responsibility. So it is opening the database for user access, and the third one is roll back the uncommitted transactions with the help of undo tablespace. So to understand what is meant by roll forward and what is meant by roll back, after these points 2 and 3 we have an example. So example 1 and example 2 both are there. So example 1 is going to explain you about what is roll forward, and example 2 is going to explain about what is roll back. So here I am assuming there is a redo log file and log writer started writing it to them. So it has started writing into the first file and it completed writing 1, 2 and 3. So here 1, 2 and 3 are nothing but the SCN number. Let's assume in that way. And after writing some redo entries pertaining to 3, because the first redo log file is full, a log switch occurred. And you know what happens during a log switch? The first thing is checkpoint event will occur, and the second point, checkpoint process will update the latest SCN to data file header and control file. So that is where you can see here, assuming this is my data file. So data file header contains the latest SCN. So here the latest SCN is 3. So the 3 he has written here. And even in the control file also the same SCN will be written. So here also it is 3. Then second step, DB-writer will write the dirty blocks to the data files. So DB-writer has completed assuming writing 1, and DB-writer has completed writing assuming 2, and DB-writer completed writing assuming half of 3. Now here the point is, why only half of 3 was written? The reason is, the next half of the 3 will be written only when this log switch occurs. So till the time we need to wait. So what Oracle will do basically is, it is going to write the first transaction completely because it was already written to redo log files. And one more thing is, whatever the underlying you are seeing, assuming this is committed. So a commit line, that means your transaction 1 is committed, your transaction 2 is committed. So 3 got committed in the next redo log file. So like this we have the scenario, and log writer started writing into second file. So it completed writing all the redo entries regarding 3, and then now it is writing redo entries regarding 4. And assuming log writer is still writing 4, the task has not yet been completed. So in this scenario, when log writer is writing transaction number 4, all of a sudden assume the instance crash occurred. So like as I said earlier, it could be a power failure or RAM got corrupted or something like that. So in those scenarios, you will be getting this scenario, instance crash. So when log writer is writing transaction number 4, assume instance crash occurred. Now when you restart, S1 need to take care of doing instance recovery. So that is what the few points explains here. So is this scenario clear for everyone? Okay. So now when S1 is bringing up the instance, so it need to perform instance recovery, and as I said earlier, instance recovery is going to happen in these three phases. The first one is roll forward, which is nothing but the comparing the SCN numbers between redo log files and data file header. And the ultimate goal of roll forward is to make sure that the committed data is returned to data files. So the ultimate goal of roll forward is to make sure that whatever the committed data is there, so it was returned to the data files. So let us go and see how SMON is going to work here. So first, as I said, it is going to compare the SCN number. So what it will do is, it will try to compare is 1 equals to 3 or not. Definitely 3 is greater than 1, and 1 is committed. So as I said, this underline is nothing but the commit point, and also the data of 1 is completely there in the data files. So here you can see the diagram. Data regarding 1 or pertaining to 1 is completely there, and the data regarding 2 is also completely there, but the data regarding 3 is not completely there. So in this scenario, what SMON will do, SMON is going to move from first redo log file to second redo log file, because in the first redo log file it couldn't able to get whether 3 is committed or not. So to understand whether 3 is committed or not, SMON will go to second redo log file, and when it is scanning, it can understand from this line that somewhere even 3 also committed. So that means even though here the situation is like this, even though transaction 3 got committed, here only half of the 3 is there, but the rest of the half data is not there. So now for Oracle, what is the responsibility or what is the task now is to just go and write the remaining half of the 3. So only half was written, so the rest of the half also need to be written by Oracle. And because SMON detected this, and that there is some data mismatch, so SMON is going to ask DB-Writer to do the job, but when DB-Writer goes to instance, that too especially the write list, it couldn't able to find any data. Why? Because just now instance got restarted, and already instance is going to reside on RAM, and the RAM is volatile in nature, so definitely our instance or the database also will be in volatile in nature. So that's the reason when SMON asked DB-Writer to write down the data, then DB-Writer, even though it will go to the write list, but it could not able to find any dirty blocks. So what it will do in that case is, DB-Writer is going to take the help of server process, and server process will go to the database, and it will generate some new dirty blocks with the help of this column in redo entry, that is new value. So what S1 is going to do, it is going to first understand whether 3 is committed or not. If it is committed, then it will make sure how the half of the 3 was written and the rest of the half was not written. So if the rest of the half was not written, then it is going to take the help of server process, and then it is going to write the rest of the half also. So by which the complete data will be there, or the complete data will be returned to the data files regarding the 3. And in the same example, we have transaction number 4 also. So, but still Oracle doesn't care about the transaction, because during the time of instance crash, either this transaction is not committed or even not it is getting a rollback. So that's the reason it is going to just leave the transaction code as it is. It is not going to worry about it, because ultimately as a DBA or as an end user, having your data is there or not is what important. How that data is there and all, it's not merely an important one. So that is what basically S1 doesn't care about transaction number 4. So in this entire process, this is example of a roll forward. So in this entire process, the one which is critical is redo log entries or redo entries. So if you don't have redo entries, then S1 could not be able to perform this roll forward task. Similarly, we have another example where a small difference is there. You can see in the diagram. So in this diagram, 3, assuming 3 is a very big transaction. So log writer finished writing into first file and log writer started writing into second file. And in the meantime, so 3 is not committed here. So in the meantime, instance crash occurred. So what happens is, the same procedure will be followed. It is going to verify whether this SCN number and the current SCN number is greater or not. And then because log switch occurred, the data of 1 will be completely there in the database, data of 2 also will be there completely, and data of 3 will be there partially. Because 3 is not committed, what Oracle need to do is, it need to just roll back this transaction, and it should not make 3 as committed. Okay. So that is what we need to do, because 3 is not committed. We don't have any authority to keep that data permanent in the database. So what Oracle will do is, it will roll back this transaction number 3. And to do a rollback, definitely I require old values, and you know it already, old values will be stored in undo table space. So with the help of the data which is there in the undo table space, you can roll back the transaction, and with the help of new values which are there in the redo entries, you can do roll forward. So roll forward means committed data should be made permanent. Rollback means any uncommitted transactions are there, the values should change back to the original value. So is these two examples clear, or any queries you have? So that is the primary responsibility of S1, and apart from that, there are 2 more responsibilities for S1, as you can see on the screen. The second one is it is going to coalesce the table spaces which are defined as automatic segment space management. Now what is meant by coalescing, what is meant by this automatic segment space management, etc. We will be discussing during table space management, so just wait till that time. And the third one is it is going to release the temporary segments which are occupied the transactions. So suppose user A is doing some sorting, then you know already that temp table space will be used, and let's assume that user A has completed the transaction and that user is out from the database. Now what happens is user B comes into the picture and user B wants some temporary table space area, but assuming earlier A has used all the space, then we can't go and create some new space because it should go and use the existing one. So when A got completed its transaction and before giving the temp table space to B, then somebody should be there to clean up, and that is nothing but our SMON. So SMON is going to clear the temporary segments, so whatever the transactions got occupied with. So those are the two other responsibilities of SMON. And coming to the responsibilities of PMON, the first responsibility will be releasing the locks and resources held by abruptly terminated sessions. But well before that, you need to understand about what is lock, etc., etc. So whenever you are performing some DML operation or some DDL operation on a table, then other user, let's suppose you are doing the one DML and your friend is also trying to do one DML activity. So both DMLs will not get completed, and you would be getting some kind of waiting state. So that means two DMLs or two DDLs or one DML and DDL is not allowed on a table. So why we require this is just to maintain the read consistency. So that is what the note under the first point talks about. So it says whenever any user performs any DML operation on a table, the Oracle is going to apply a lock, and this is to maintain the read consistency. So when suppose there was a session which set select star from EMP, so server process received the statement, but meanwhile let's assume that user process got terminated. So in that case what happens is a lock, whatever the lock that was held on the table, so that lock will be there as it is, and then PMON need to come into picture in order to release that lock. So that is what usually happens. And apart from that, we know the responsibility of PMON is going to authenticate the user, and the third one, it is going to register the listener information with the database or with the instance, and finally it is going to restart the dead dispatchers in case of share server architecture. So we will be seeing the last 2 points or the last 3 points at a later point of time. So any queries over here? Okay, so then we have database writer. So the responsibility of database writer is to write the dirty blocks from the write list to the data files, but there are certain events when DB writer will do this. So DB writer will not keep on continuously writing into data files, so rather it will do this activity only after a certain period of time. So for example, there are some situations you can see on the board. So whenever log writer completes writing, then DB writer will write. We already know that. And then whenever the write list reaches the threshold value, suppose write list got 95% full and it's so busy that everybody wants, you know, or everybody or every transaction is generating some new uh, dirty blocks, then automatically the write list will be also becoming dirty. So in that case, also first log writer will write and then DB writer, and then at every checkpoint event. So whenever checkpoint event occur, even DB writer will write, or whenever you are making a table space offline, or whenever you are placing the table space in read-only mode. So in all these scenarios, and also when you shut down the database very cleanly. So these are the 5 scenarios when DB writer will write. Similarly, there are some scenarios when log writer will write, and we know already log writer's responsibility. It is going to write the content from log buffer cache to redo log files, and it is going to do this activity in below situations. The first one is before DB writer writes. So do remember, always log writer will write first and then followed by DB writer. And this process usually we call it as write ahead protocol. So in your class notes also it was given as a note under DML processing. So log writer writing before DB writer, we call it as a write ahead protocol. And so that is how we have the things in place. And number 2, the second situation when log writer can write is whenever commit occurs. And the third situation whenever log buffer cache is 1/3 full, and the fourth one whenever 1 MB of redo is generated, and then every 3 seconds. So these are different situations when the log writer will write. And then we have CKPT process. So just now we discussed a while ago. CKPT process responsibility is to update the latest SCN and to the data file header and control file. So that is the only task for CKPT. And then we have archiver. So just now we discussed it. Archiver is going to generate the backup of the redo log files, and that too only when the database is in archive log mode. So those are the mandatory background process that we have in database. And apart from that, 10G and 11G got introduced with some new background processes. So whenever we require, we will be discussing about these background processes. So whenever we see a particular topic, we can go through those background process, other background processing. So any queries over here? So then we have the definitions for data files, redo log files and all. So data files are nothing but the actual location where the user data is going to be stored, and redo log files, just now we discussed, it is going to contain redo entries, but the log writer will write to them in a cyclic order. Then control files. So till now we have never discussed about control file. So what basically control file contains is this one. So it contains the database name and creation timestamp, and also it contains the latest SCN. And number 3, it is going to have the location and sizes of all the data files and redo log files. And finally, there are some parameters which are going to define the size of control file. So we will be seeing these parameters list in backup and recovery. Then I can explain in more detail. And then we have archive redo log files. So these archive redo log files are created by the archiver process, and that too when it is in archive log mode. So those are the files that we have. And the next one is a parameter file. So already I have shown you about parameter file in the other day, that without parameter file even you can't start up your database. So that is a very critical file to be there in the database. And what it basically contains is the parameters that will define the characteristics of database. For example, we have seen already so many parameters like PG underscore aggregate underscore target, then shade underscore pool underscore size, all those things. So these parameters are basically either to allocate the memory size or might be to specify or to define something. So we have so many parameters in place. For example, if you go for 10G, you have around 260 plus parameters, and if you go for 11G, you may find more than 330 plus parameters. But fortunately, we don't require to remember all the parameters, but at least some important parameters we need to remember. So the first point is going to talk about that the parameter file contains the parameters which will define the characteristics of database. And second point says the parameter file is a text file and it is going to reside in the form of like this, like init, then sid dot ora. So here sid means instance name, and it is going to reside in the location oracle underscore home slash dbs if it is a Unix machine, and oracle underscore home slash database if it is a Windows machine. And for example, if your SID is test or XYZ or something like that, then you can use the file name as init, that XYZ.ora. And the parameters inside the parameter file can be divided into two categories. One is static parameters and the other one is dynamic parameters. So static parameters means the value of those parameters you cannot change when the database is up and running. So one such static parameter that we have is log underscore buffer. So if you want to change the value of or change the memory of log underscore buffer, it is not possible when the database is up and running. So you can change only when the database is shut down. But when it comes to dynamic performance or dynamic parameters, then you don't require to shut down the database. You can change the values up and running when the database is up and running. And there was a note also which says the instance name can be different from the database name, and this is to provide the security. So that is what the parameter file is about. Now let me show you something. Okay, so as it is mentioned here in the class notes that the parameter file will be in the form of init sid.ora and it is going to reside in this location oracle underscore home slash dbs. Now what exactly is this oracle home is nothing but the location where you are installing oracle software. Suppose I am installing my software in U02, then some location, some subdirectory, then we can say that as our oracle home location. For example, in one of the servers here, I have installed oracle home binaries in or I have installed oracle software in this location, and that means this has become my oracle home. So that is what it happens. So oracle home is nothing but the location where you installed oracle software. Now under Oracle Home you have a DBS location, and under DBS location you will be having this parameter file. So in the form of init, then sid.org. So that is the usual thing what we have. And the extension to the parameter file. So parameter file is basically a text file. So anybody can open with proper access, and they can change some values. So all that things are possibility is there. So to avoid that, what we will be doing is we are just Oracle has just initiated another version which we call it as server parameter file, or shortly we call it as SP file. So this SP file's nature is, it is a binary file. So as it is mentioned in the first point, so this file is the binary copy of the P file, and which is going to provide different options in changing the parameter values. So whenever you want to change one parameter value, either you can do it immediately, or you can do it from the next startup, or you want both. That means you want to change now also, as well as you want to change in the future also. So based on that, you have these three scopes. So if you say scope equals to SP file, that means you want the values from the next startup. And if you say scope equals to memory, that means you want the values to be effective immediately. And if you say scope equals to both, then it means that you want the values to be reflected immediately, as well as that values should be made permanent in the next startup. And SP file will be in the form of SP file sid.org, and again SID is nothing but the instance name, and it is going to reside in the same location as P file. So that is Oracle Home underscore /dbs, and here you can see my SP file. So here my database name is prod.db, so that's the reason the naming convention is like SP file then prod.db.org. And as per the third point, always Oracle has given you the chance of creating SP file from P file, or P file from SP file. So you can do that always. For example, here I have SP file. Now I can create a P file out of it. So simply I need to use this command. So this will create a P file from SP file, and already my database is using SP file, so I don't require to create one more SP file. So if you look at here, you can see you will be getting a copy of P file. So SP file is a binary copy, whereas P file is a text copy. So that is how we have different one version of P file or parameter file, and the other version we have is SP file or server parameter file. And let me show you small thing over here. So there is a parameter to define the size of PGA. So we have already seen this theoretically. So the parameter name is PGA underscore aggregate underscore target, and right now it was pointing to 150 MB. So suppose if I want to increase this value to 150, from 150 to some other value, then definitely I would be requiring that particular memory available. So, and not only that, first I need to decide whether I want to change the value immediately, or whether I want to change this value in future, or whether I want to change the value immediately as well as in future. So first I need to decide and then based on that we are going to decide the things. So for example, I want to change this value immediately, then we will be using the command like this. So anyway, we will be seeing the commands in detail at later point of time. So I'm just giving a brief overview. So if you want the value to be taken immediately, then we are going to use scope equals to memory. So what happens is the value of the PGA size will be changed immediately. So you can see here the value was changed to 200 MB. Suppose you want the value to be reflected in the next startup but not now, then you can simply say, for example, I want to change the value to 180 MB, but I want this value to be effective from the next startup. In such case, I will be saying scope equals to SP file. And because I said scope equals to SP file, so the value will be reflected only in the next startup. So that's the reason here you can see it is still pointing to 200 MB. So now what I will do is, I will just shut down the database and I will start up. Then what it will do is it will point to 180 MB. So this one. So then I'm starting up my database. And now if you look at the PGA size, you can see it was pointing to 180 MB. So this is how it is going to happen. And if I want a value to be done both immediately as well as in future also, in such case I can say scope equals to both. So in this situation the value will be changed immediately. You can see here from 180 MB it got reduced to 150, and not only that, in future also how many times you restart the database, this value will stick to 150 MB only. So as I said, parameters are categorized into dynamic and static types. Where dynamic parameter means you can change the values when the database is up and running, and static means the parameter values you can't change when the database is up and running. So definitely you require a database restart. The most unfortunate thing for us is no Oracle book or not even any blog or any material is going to give you the list that these are the static parameters and these are the dynamic parameters. So that means you can't find anywhere which is a static parameter and which is a dynamic parameter. So you will come to know that only with experience of using it. So you experience it that, or you try to change that. If you could not able to do the change when the database is up and running, that means it is a static parameter. So if you can do that change immediately, that means it is a dynamic parameter. So basically we can get only those things with experience, not with any Oracle book or any other Oracle blog. So any questions we have here? I hope with my last statement, I think Raghu, your question got answered. So any more queries from anyone? Sorry, I could not able to hear the voice.
I was asking about the init file.
I mean, your voice is not at all audible to me. At least somebody other, some other, can you people able to hear? Okay. Okay. Fine. Yeah. So here, let me show you. So when you go to this location, so there will be a file called init.ora, and there will be another file called init.dw.ora. So basically these two files are sample files. So if you don't know what parameters to be there in the database, and especially when you are creating the database manually, you may need this sample file. So when you open it, basically you will be having the details like what are all the different parameters that you have on the what is the minimum value, what is the maximum value for each parameter. So it is going to list you all that information. So this is for the general database, and if you are creating a database for the data warehouse environment, then you will be having one more parameter file. So you can see here, it is an example of init.ora file for the data warehousing applications. So these are some sample files that Oracle will give you whenever you install Oracle software. So, but we don't use them in real time also. Neither we are going to use them here in practice or even in real time also. So we don't require to worry about it. So any other queries? Yeah, Raghu, this is not the right time to discuss about the commands because still we are in theory part. So whenever that situation arises, definitely I will explain about those commands. So I hope every one of you got the material, the soft copies. If not, please contact Vishnu on his mobile or the email ID. But as far as my knowledge, everybody got it. So anybody there who have not received the soft copy? Okay. So just go through that material. Whatever I am showing on the screen, it will be of same thing. So tomorrow we will be discussing about this automatic shared memory management and the rest of the portion. So any more queries from anyone? Okay. So then let us meet tomorrow at the same time. And from tomorrow onwards, we will be going with 1.5 hour session completely. So I mean, as the promised time, so 8:30 to 10 o'clock, we will be going through that. So so that we can cover much more topics. So thank you everyone for joining today's meeting, and let us meet tomorrow.